Hi everyone, welcome back. Today's problem is, which factors affect the period of vibrations of a spring pendulum? We'll return to this in a little bit after some background and terminology. Alright, let's go over some terminology. Displacement is measured from the point of equilibrium. It's delta x. Amplitude is the maximum displacement. That's equivalent to the radius r in uniform circular motion. A cycle is a full to and fro motion. This is the same as one trip around a circle in uniform circular motion. Period is the time required to complete one cycle, and frequency is the number of cycles completed per second. For simple harmonic motion, we also must recall equations from uniform circular motion. We must remember that velocity is equal to 2 pi r over t, and velocity is equal to 2 pi rf. Let's go over what happens when the spring is at equilibrium and heading to the positive direction. We must know that the displacement is 0, the force on the spring is 0, the acceleration is 0, and the velocity is positive and at a maximum. Alright, so what happens when the spring is all the way stretched? The displacement is at a positive amplitude, the force of the spring is the negative direction, the acceleration is in the negative direction, and the velocity is 0. So what happens when the spring is at equilibrium and headed in the negative direction? Again, the displacement is 0, the force of the spring is 0, the acceleration is 0, and the velocity is negative and at a maximum. Now let's relate this to energy. When the spring is passing through the equilibrium, elastic potential energy is 0, kinetic energy is at a maximum, and total energy is constant. Now when the spring is all the way stretched, elastic potential energy is at a maximum, and kinetic energy is 0, but total energy is constant. Due to the conservation of energy, the energy total in this is elastic potential energy and kinetic energy. At this moment, go over this derivation of period and frequency for a spring pendulum. Let's return back to the purpose. Which factors affect the period of vibrations of a spring pendulum? Alright, so what do we need for this lab? We need a spring stand, two masses of different mass, and two springs of different spring constants. Well, what happens if the mass of the hanging object is changed, but the spring constant remains the same? Also, what happens if the spring constant is changed, but the mass remains the same? Alright, so what did we say? We saw that period and frequency of a spring pendulum are dependent on the mass of the hanging object and the spring constant, as seen in the equations for period and frequency of a spring pendulum. Thank you for your participation in this online lab. I'll see you next time.